Hi and welcome to this new video tutorial. We have today a Raspberry Pi, a webcam and a servo motor. Our goal is to move the webcam using this red object. So where the red object goes, also the webcam moves. So we simply do this way. We have and also you must be careful to set up the right lighting condition for the red, or otherwise it will be a bit messy. Anyway, we take a servo motor, we put above the webcam this way, and this is an MG996R servo motor, which is you find on the market below $10 each. And the characteristic of this servo motor is that has an angle which goes from 0 to 180 degrees, so it can make only half circle. So our goal is, with the webcam, we say the angle where the red object is. In this case, let's say in the middle is angle 90. On one side, half circle is angle 0, and then on the other side, slowly going, it will be angle 180. So we will see now, using Opencv and Python, how to send a command from the Raspberry Pi using the webcam. And also keep in mind that to command the servo motor, we are using a servo head placed on the Raspberry Pi. Let's get into the coding of this part. Okay, let's start right now. Our first goal is to take the frame from the webcam to see the position of the object, and only then we will work with the servo motor. So first we import CV2, then we import numpy as MP. We load the capture cap is equal to cv2.video capture 0, which stands for the first webcam. If you have different webcams, it can be different index, like 1, 2 and so on. Now let's run the while loop. While true, and we take the frame underscore frame is equal to cap.read. Now let's show the frame on the screen. cv2.im show frame and then frame, and we create a wait key event. Key is equal to cv2.wait key 1. If the key is equals to 27, which is the S key on the keyboard, we break the loop, and then we release the camera cap.release and cv2.destroy all windows. Keep in mind that on the Raspberry Pi Raspbian, cv2 destroy all windows is really important, as if you don't put this one, when the execution of the code is done, still you will see the windows open. So never forget this one on the Raspbian. Okay, once we have this, we need to save the file, and we can run the file to see if we can get the frames from the camera. So save control camera with servo. Run the script, just pressing this play button, run current script, and this is the servo motor pointing, this is the webcam just pointing on one side. Now the next step is to get the red object, so we need to find the red object using the HSV color spaces. I've done a video about this, how to detect objects by their colors. You can watch it on my channel, and I will do that really quick here anyway. So as we need to find the object using HSV color spaces, first we need to convert the frame to HSV format. HSV frame is equals to cv2.cvt color frame, and we're going to convert the frame cv2.color from BGR format, which is 3-channel format color, blue, green, and red, to HSV, hue, saturation, and value, that I've explained in the other video. So if you're interested to go more deep into the HSV, just check my other video. And now let's move on. We have the HSV frame. Now we need to find the red color. So we go below and we say red color. We need to define a range of the colors, the low red and the high red. So low red np.array, and we need to define the lowest value of H, S, and V. In my case, it's 161, 155, and 84, the low red, and the high values, high red, is equals to np.array 179, 255, and 255. And from this we can get a mask. So we get red mask is equals to cv2.in range of the HSV frame, and then low red and high red. And we can now show the mask. cv2.im show mask and mask, red mask. And let's see the mask on the screen. And with this mask we should detect the red object. We don't detect anything, or almost nothing. You can see, okay, now as the lightning condition changes, we can see the red color detected. Of course you can adjust these values. Now it's not the optimal on this lightning condition, but anyway, as we can see something of this red, it's fair enough for us at the moment. So we can say that the red object has been correctly detected. So now let's move on. From this we want to find the contours. Our goal, okay, I will run again the script. Let's say that we have a red object. We have this red object, for example, and maybe on the background there is some other red, like this one. The other red, we can see that there is some detection. You can see that white part on the mask is the detection of that red, and that's some noise. And then we have this red. So we can either remove the noise, or a simple and more reliable operation will be to detect the biggest red object on the screen. So in this case we'll detect just this one. So we take the contours of all the red objects, we find the area, and only the biggest one, we take that. Let's go. The underscore contours and then underscore is equal to cv2.find contours on the red mask, and then cv2.ret 3 and cv2.chain approx simple. And also I've done a video about finding contours on an image. So if you want to know more about this, you can check my other video about contours. And now let's move on. As I said, we're going to take the one with the biggest area to take only the biggest red object. So contours, we're going to put them in order from, we're going to sort them from the biggest to the smallest. So just copy this function sorted is equals to contours, and then key lambda x cv2.contour area. So with this lambda function we're going to calculate the area of all the contours, and this will put all the contours in order. Now we're going to reverse this one. Reverse is equals to true. So instead of having them from the smallest to the biggest, we will have from the biggest to the smallest one. And that's enough for the contours. Now I could show this one on the screen, CV2, let's say contours, let's see what we get. We could draw them on the screen, or let's just draw a rectangle on the biggest contour. So it will be for CNT in contours, we take only the rectangle. So x, y, width and height is equals to cv2.bounding rect of each contour. So simply we loop through the contours from the biggest to the smallest. Of each contour we take the rectangle, and now we draw the rectangle on the screen. cv2.rectangle on the frame. The first, we know that from the rectangle we need to have top left point and bottom right. The top bottom is x and y. Sorry, not top, the top left, and the right bottom is x plus width and y plus height. And now we define the colors. Let's make it green 0 to 55 and 0, and to the border 2. And now we can show this on the screen. Let's see what we get. Now all the object, we have the rectangle for each red object detected. I forgot that we need to only to work with the biggest one. So as we are looping from the biggest to the smallest, first one we draw on the biggest and then we break the loop. We are not interested in the other one. We break, and so with just this simple operation we will get the contours only of the red ball because it's the biggest object on the screen. Fair enough. Let's now find the middle of this red ball so that we can give this coordinate to the servo motor to move on the screen. To move. Simply to take the medium of the x is in geometry we need to take the first x plus the second x and divided them by 2, and we will have the medium point. So x medium or median, I don't know, let's call it just medium, doesn't make any difference the name of the variable, is equals to the first x plus the second x. So the second x is the first x plus the width, plus x plus width, and all of them divided by 2. And we need to also keep in mind that the x medium, as it's a pixel, has to be always an integer. We cannot draw the pixel 320.5, for example. It's either 320 or 321. And this, we close it, this way. Okay. We draw them. We have the x medium, so we can draw the x medium on the screen. And we don't need to show anymore the red mask. Let's instead draw a line for the x medium on the screen. cv2.line on the frame. So to draw a line we need to take x medium, and we make the line start from the top of the screen, so point 0, to the bottom of the screen, so x medium, and then Usually when we take the frame, it's size 640 of width and 480 of height, so we'll say 480 to take all the screen. And then 0 to 55, 0 and 2. And now we have a line in the middle of our red object. Let's see an example to see if everything is detected correctly. And that's our goal. We have the line. Now we are almost done. Actually, we are done with the detection of the red object. Now it's the part of the servo motor. How can we do this? So we know that where it is. So as I said before, this servo motor go from 0 to 0 here to 180 degree. So we need where the middle is 90. So let's start from the middle position of 90 degree. We define a position. Position is equals to 90, and then it would be 90 degrees. It's just a comment anyway to make it more clear. And then we need to load the servo motor. We from PCA 9685 import PCA 9685. And by the way, this is not for everyone. I mean, I'm loading the servo motor this way because I have a servo head which uses this file. So to work with the servo motor, it depends the servo head that you have, and you need to use another library. In this case, I built some part of this library to work with specifically my board, so you will have to figure out this one by yourself. And now I create an object to run the servo motor, so using this library, and I will go this way. PWM, which stands for pulse width modulation, is PCA 9685, and then 0x40, and the bug is equals to false. I need to set the frequency pwm.set pwm freak 50. In this case, it's for my servo motor MG996R, which works with this frequency. And now I can work with that. As first thing, I want to put the servo motor in the standard position, which is the middle, so 90 degrees. So I can start already giving the servo a starting position. So it will be pwm.set servo position. I can connect from 0 to I can connect 16 servos to my board, and each servo, each position has an index. This is the servo 1, servo index 0, and I need to set the degree position, so 90 degree will be the center. So now that the servo is in the position 0, it is going to move. So I run the script. You can see I click run, and let's see what we get. Really quick, the position, the webcam moved in the degree 90. And also we got an error. Let's see what the error is. Name X medium is not defined. Okay, the problem is that we are drawing the line using X medium, and this line is calculated by the biggest red object. But in this case, there was no red object on the screen. So we get the error that X medium is not defined. So let's give an X medium a middle position. Let's start X medium from the middle of the screen. So we simply take from the cap, let's take the frame so that we can take the width of the screen, underscore frame is equals to cap.read. We take just a frame so that we can have the position. And then from the frame we can take rows, which is the height, calls, which is the width, and the channels, and it is equals to frame.shape. So the X medium will be calls, X medium is equals to calls divided by 2, and keep always in mind that this must be an integer. So int, because we cannot divide a pixel. If, for example, we are going to divide 501 divided by 2, it will be 250.5. It cannot be 250.5, either 250, either 251. X medium, let's go ahead from X medium and position 90. Okay, now it's really simple. The idea is, if the X medium is less than the center of the screen, which is this one, then we need to move the servo to get to the center again. So let's say also that center is equals to the same position. Center is equals to this one. Let's now try this way. We go, for example, at the end of the loop here, let's say move servo motor. If the X medium is less than the center, if the X medium is smaller than the center, we change the angle. So the position will be position equals to plus or equals 1. And if X medium is bigger than the center, then the position is minus or equals to 1. Let's see with this what we get. And I forgot to send a command to move the servo motor after this one. pwm set servo position. Set servo position and then position. Because we start from position 90 and then we're going to change the value each time. I'm moving the object and the servo is, let's say, correctly following the object, but is never stable. And so let's assign a wider center to avoid this problem. So we can say if X medium is less than center minus 20 pixels, for example, and X medium is greater than the center plus 20. So in the middle we are assigning, there is the center. Let me save this and let's try to explain visually. There is the center and then there is a range of 20 pixels on one side and 20 pixels on the other side. So there is a range of 40 pixels, which will be enough to stable the camera, to make the camera stable. Actually, I did this already 20 and wasn't working perfect. Let's say 30 pixel. Okay, let's try with this one. Let's see how it works. So a range of 60 pixels. Okay. Raspberry Pi, it's a bit slow to make the calculation of the video, so we can improve a bit the speed of this to have a more smooth movement just by making the screen smaller. So let's change the size of the screen. We can say on the video capture, we can say cap.set, and we have width and height. At the moment we have a resolution of 640 by 480, so let's make 480 of width and 320 of height. So cap.set 3, which stands for the width, and width we say 480, and then cap.set 4, which is the height, and we say 320 pixels. And we can run the script right now, and we can see that the screen is much smaller, and it works really well. We could improve the speed, for example, giving a higher degree to the movement of the servo motor. For example, instead of only 1 degree at a time, we can change of 1.5 or 2, for example, degrees. Let's try this way, and it will be faster movement. You can see, and this is a great result that we achieved. So this was a really simple project using the Raspberry Pi, the webcam, and the servo motor. I will show you my servo head. So we have the Raspberry Pi, and here I have another small board that I attached to the GPIO of the Raspberry Pi, and you can see there are 16 channels where I can put until up to 16 servo motors. And of course there must be some extra power, which I'm giving with 4 batteries to power the servo motors. And all of this about servo motors and Raspberry Pi, it's part of my new video course that I'm recording right now. It will be a really advanced video course where we're going to build projects that will be really useful on working environment. For example, with conveyor belt for some automation or building company, or for example using robot arm where the camera sees some object and the robot arm will do some operation with the object. And all of this can be done with the Raspberry Pi. If you want to know more about the course, I will leave a link below in the description where you can stay updated about the release date and all the subject that we are going to cover. This is all for now, and see you in the next video.